Okay, so now that you've seen what the tool settings are, let's go under the hood and let's actually see the network. So I'm just going to increase this a little bit, and I'm going to allow the editing of contents, so I can jump inside and sort of show the different sections. So there's my trail curve geometry, jump inside that, and I've sort of organized it in different parts. So I'm just going to talk briefly about what the different parts do. So this is the entire network, so it's quite a bit, and on top of that there are sort of, the micro tools, the little digital assets in there. So I'm going to flow along with the network as it goes. So the input geometry kind of comes in, and we've got the moving, the rest geometry, and the curve geometry, and they are then from there fed into either the sorting operations, so we can sort of, sort basically based upon the strings or the curve or just the normal sorting operations, and there's switches. So for instance, if I jump in one of my assets, which is sort by curve, I jump inside, then there are a bunch of nodes in there as well again, so you can kind of go through those networks and see what they do. They will basically, do the sorting by curve. And every asset as well on its own has got a bunch of parameters, which are, these are very small tools, so there's not too many settings, but they will allow you to, manipulate, do one specific task. It's like a function in programming. Okay, so then from there, if the sorting has gone through, then we start scattering, right? So we can either scatter on the base geometry, or we both scatter on the base geometry, but one is for the generation of the trails, so that this scatter will sort of feed into the copy sub, and the other one is for the mesh generation later on, so that we can turn on the first, sort of a bunch of scattered points in the beginning and a bunch of scattered points in the end, and this will go all the way down later on into the mesh generation. But let's go to the other side. So again, these scatter subs as well, have got their settings as well. Okay, and basically there's the copy. So we have got lines with local randomization if wanted, which is unfortunately not yet implemented, but or just points, and these are copied onto whatever input, so this sorted or scattered input is then being used. Then from there some attributes are generated, some primnum attributes, which will make every point a unique point, so that it can be used later on to identify the individual trails, right? Then what we do is we basically create sort of different types of calculating the velocity. So either it uses the velocity of the base surface that's incoming, and it's already been, it's already in the incoming base mesh, or you can compute the velocity, or you can use later on the velocity of the particles. So basically these are variables that are being defined now, and then potentially later on be used to override the velocity of the particles. Okay, so what's going on here? I've got the lookup context and trail particles. So one part of the tools are the ramps. So there's the simple ramps, and if I just go into my context, there's the simple ramps, and there's the sort of ramps that have got 5 sections to them. So if I just show this briefly, where is my compositor? It's a bit hard to see, but there are 2 ramps in there. There's basically the yellow to whatever color ramp, and there is the white to black ramp in there. And these are very sort of thin strips, because I don't need anything more than 1 pixel basically. So I've got about 1,000 values to sample from. Okay, so that's for where the ramps go. That's the animation curve. So basically I go and fetch the curves from my operator, then I isolate the color values, isolate the size, and basically over there this is some mathematical operations just to stretch them out and put them in between the correct range. So when I go inside of my trail particles, so this is where the actual trail particles are generated, the geometry comes in, right, and then a color is assigned. So depending on which kind of color settings you have, different kind of color lookup values are happening. So what is going on here, for instance, if I just open up one of these expressions, right, just to show, I'm using the integer pick. Pick stands for the lookup for the from cops. So basically bring in the data from cops and multiply it with the p color value, and the p color value is defined outside outside of the particles. So it's basically defined above it, sort of over there, point color attribute create. So there's the p color, and it basically just gets the color from the surface. So that was the case if it was inherited, and then it's basically just transferred. So some of these values are used to tint so this is to tint the color. So that was a multiplication that we just saw. So this is a multiply, so that's tinted, right? Some of them are, however, just normally assigned, so that's just a simple expression, same expression but without the multiplication, and that's done for every channel. And the life over there, the life of the particles, is driving this. Now the problem with this is that if I change my color, I have to rewind my particles, and actually later on, as I was generating this tool, and I learned a method of sort of doing the lookup outside of the particles, so the particles do not need to be rewinded. And I implemented this for the size, the p scale, so the point scale, but not for the colors yet. So this entire network for the color and the alpha can actually just be taken outside of pops, and the advantage is then, you don't need to rewind your particles each time, so it could be a lot quicker. So same thing, the same lookup values. So you've got the source, the ramp, and the anim curve. So the anim curve uses sort of the chop function, so to reference that, again using $life but times 100, because my range of my channel is between 0 and 100. Alright, then basically this is where the forces are being applied. So a bit of drag, wind, and gravity. All these forces are linked up, so they are linked up relatively to the parameters of the digital asset of the trail tool. Oops. Let's get rid of that, and then basically we go back out, right? Okay, so what I'm doing there is I'm using the base velocity instead of the particles velocity, because the particles, if I add some forces to them, they get some velocity, and I can use this. I can either use this one, or I can transfer the velocity that is coming from the surface and just ignore the velocity from the particles. So that would give me the movement of the particles with the velocity of the base surface, and that's what's going on in this area. Then basically this is where the velocity is multiplied with the alpha values of some of the curves. So you can switch, to define which curve is, or which ramp is being used, and this will basically change the velocity value over the length of the curve. Okay. Now this entire green network box is the trail curve loop. So this is one big loop that will run through all the particles. So if I just display this at this stage, what I have at this stage is just a bunch of particles with numbers, right? And as you can see, the lowest numbers are sort of at the bottom, and they go higher as we go. But I've got basically a bunch of points forming my curves. So what I'm going to do is, these points have got unique numbers. So all the points associated with one point on the surface have got unique numbers to them. And now I can basically use and sort of do a for loop, as if it was a for loop, and delete the points that I don't need, build my curve, and basically keep on doing that. And then as a final output, what I will end up with is a whole lot of copied curves. So if I just visualize this part, I end up with curves that have been copied. What I can do then is use these curves and use them in the order that they were sort of assigned, and use them to skin a surface. So that is where the skin surface comes from. Okay. And basically a lot of switches control some of the parameters in the meantime. So yeah. Then when the curves are being computed, just in the copy sub, so I'm just going to show the copy again, they also get normals assigned to them. There are two over there there's a resample subnetwork, and there is the normals sort of assignment to it. So if I visualize my normals, then I can see over there that they are pointing in the direction along the curve, right? So this is sort of a special little, you could make this into a tool. This is a very small sort of tool, so I didn't really, you know, put it into its own digital asset. But this basically uses the edge force over there under the force parameter. This is quite a useful thing to know. Adds an edge force, it creates the edge attribute, it uses these different components, and then basically assigns these components to the normal, and then to clean it up, get rid of these attributes that have been created as an edge force, because I don't need it as a force. So the resample, this is where the potential polygon resampling goes through. So yeah, if I jump inside there, then this is an example that uses that basically gets the curve points and will loop through and will either smooth them or not. In the end, this is not really being used, but I mean, this is only being used, sorry, if you turn on polygon resample. Okay, so let's move on. The normals then, if we do want to calculate the normals, then we can just visualize them there. So these are now the surface normals are being calculated by a facet sub, and potentially reversed if necessary. Okay, so then from there, this is everything we need to know to go into the different outputs. So either we just straight away use the curves and go down into the render, right? So basically we just stream down this switch output curves, or we switch down to output particles, and what's happened in output particles is for the resulting skin surface, right, it's coming into the pops, it's coming into the pop network, right, and every single frame, as you can see over there, every single frame there are particles emitted onto that resulting skin surface. Every single frame they are born, and every single frame they die. So there is no sort of lag or consistency. The problem is that if you don't have enough particles, this will cause jittering. The idea is to have huge amounts of particles, like 500,000 particles or so, to get this kind of thing going. Okay, then some of the surface is also being used as a base for scattering some points on, because these points, these scattered points that are on the surface, will be used to sample the velocity from. So the velocity vector that is assigned to the surface will then be transferred to the particles based upon these points. So as you can see over there in the velocity, the velocity attribute is transferred. Okay, so then I've almost got what I need except for the point width. So the only thing I need there is the point width coming from my settings, multiply that with the p-scale. And the p-scale, the particle scale, is being assigned somewhere along the line there. Attribute create p-scale. So in the multiply the v and the p-scale, so multiply the velocity and the particle scale lookup. So this is where the particle sort of lookup value happens. This is what I was saying when the value can be looked up after sort of the generation of the particle. So it just uses a variable called $life normal, which is the normalized life, times 100, because that is the range of my channel, and it will basically override or map this onto the p-scale attribute. Okay. And then later on, the nice thing is this will just flow down the network, and I can use it either in my particles, or I can use it in my mesh, or I can use it, you know, as for my curves with the width. Okay, so let's go from this output and go to the mesh. So the input that is coming from the mesh is basically all the way at the top. Remember where I said I scatter some points at the beginning and at the end, so I can just say, let's have a look at these scattered points. So there's a bunch of points scattered, right? At the moment the group is being used, so if I middle mouse button on this, the trail group is being used, so that is coming from the from the digital asset template group, so from the upper level. But so these are the points that are being scattered, and they will feed through all the way down if this setting is enabled, all the way down, and they are potentially being used in combination. So if they are turned on, then we would get our curves, which would be resampled at this point, merged together with the points at the start and the points at the edge, at the end, if the points at the end are enabled. So again, this geometry comes in just as a bunch of points, like this. Then what happens is a trailing operation takes place, which goes and samples the life of the particles and multiplies it by the frames per second. And this will basically make sure that this trail lags behind the particles just enough, just as much as needed. Then they are grouped, so the start points are grouped. So if I just rewind this, and let's have a look at this. So I've got two groups. I've got a group there and a group there, and basically this will split again the groups into two pieces. I didn't use a for loop for this because it's just two groups, and it will basically delete one group, and in there it will delete the other group, so it just gets rid of the other group. If I just rewind this, let's have a look. So I've just got this group left. The color is assigned, so the color from is looked up again from the channels. So the first color or the last color from the ramp. This is the start, so this would be the first color from the ramps. This would be the last color from the ramp or from the color from the curve. So instead of putting the life normalized times 100, I just put in 100, which is 100%, which is the maximum value. Okay, then from there are some switches which either use it or don't use the start. There's another switch as well, which then basically goes and checks if this base geometry is included or not. So this is basically just a multiplication of, or an addition rather, of these two switches. So because it's like 1 + 1 gives 1, and it's clamped between 0 and 1. So on all of my switches there are sometimes expressions, so there are no fixed values. Everything is sort of built through expressions and is relative to each other, which can make it a little bit more difficult near the end because you don't want to break your tool as you go along. But then these points are fed into my mesh generation, which uses a particle fluid surfacer, and this is basically where everything starts to come together, and the attributes that I wanted are being used, and the attributes I can, the step size and the point radius are linked up. Okay, and then basically the normals are assigned to it. There's normals now to the surface, right? And the surface is smoothed a little bit just to get out some rough edges in case there were some. Okay, and then from there, either if it's the curves or the particles or the mesh, they all feed eventually into the material. So we've got two materials. I've got a basic material and a material for the user, right? And you can switch between those two. So the basic material, if I jump inside again, this is contained. Like I said before, this comes along with the asset. So I made a little shop, a very basic sort of material. So now I'm into shops. I just jumped into shops, and I'm going to dive really deep just to show the VOP network. It's a fairly easy VOP network. So basically the diffuse color from the surface is being multiplied with the global diffuse override and the existing diffuse color. That is fed into a lighting model. That lighting model can either be used or not be used, using a little switch. So if the model is not being used, then it's just going to use the color from the surface, from these two sort of multiplication result from the product. Okay, then the pre-multiplication with the alpha is happening. So over there the opacity and the alpha values are coming in. So the opacity is a global multiplier, the alpha is coming from the individual points, and it's multiplied with whatever previous alpha was there. And then that is fed finally into the output, the out opacity. And I've connected the F so that potentially it could be used with physically based rendering, but I haven't tried this yet. Okay, so much for the shop network. So again, the channel is there for a user to plug in his own material if need be. There are then a few it basically splits off into a render out and a display out. The display out allows users to display the base points. So I found it quite convenient to see, like, if something was wrong with my trail, I wanted to see if my base curve, my base curve, which comes basically all the way from the top, so this comes all the way from the top, if you follow this sort of line, and it comes all the way from what is copied onto my copy. So all that I've got there is my curve. So if I rewind this, play this again, let's have a look. No points. The moment nothing seems to be copied, so 17 points in there should be. Let's turn on the display and let's have a look. So there we go. This is the curve that is being generated from these points. So that's my sort of base display if it's turned on, but it's turned off at the moment, so can't really see it. So there's my base curve. But it's using the entire sort of network, I guess. So let's just leave it at that. And that's a quick, brief look under the hood of this entire tool. Okay, hope you enjoyed it, and I hope to release this asset as well at some point, but it will be needing some tweaking. Some of the nodes have got comments on them. Some of the asset design itself as well is sort of smart in the sense that if I go up again once more, for instance, sometimes the values are disabled. For instance, like the sorting, you can't change any of these values unless if you enable the values. The different values are enabled depending on the different selection types. All these things, are sort of set by myself. They are not, they're not there by default. Yeah, the nice thing as well is that part of the tool design, which I really enjoyed, is you can just go into, say, the sphere object, and if you wanted to do the sorting in there, well, now you can use any of my micro tools, which could be, say, PC scatter on moving, right? So you've got a moving object and a non-moving object. So I'm going to middle mouse button, it gives me the help moving geometry. So the moving geometry would be this guy, the rest geometry would be that guy, and I can just look at it. And this is just a tool, right, which allows me to scatter points on moving geometry automatically, really quickly, random seed if I need to change it, use an input group if there is any, output group. So the nice thing about this again is that these micro tools can now be used in other tools. They don't need to be part of my trail tool at all anymore, and that's really the power of Houdini. So I hope to extend this kind of macro tool design further, in the sense that I would like to apply this to the color settings as well, so that this can become an automated sort of section that can easily be integrated into any asset, so that it can just be plugged in and be used. Okay, and with that I've covered basically pretty much everything that is in there. There are a few inconsistencies in the mesh generation with the color inheritance, because it's not as complex as the color inheritance that is going on inside the pop network, but it will work for most cases, as the meta balls will blend the surfaces together. Okay, I hope you enjoyed it, and this is the entire network. So starting with the input geometry, going down, copying, changing the velocities, switching the base velocities if possible, adjusting the velocity values and doing the lookup for the scale, doing the trail curve loop, and over there basically computing the normals if necessary, computing the mesh, computing the particles. Sorry, this is computing the start and end points for the mesh, and this is the actual mesh. This is the material assignments, and then basically the display is coming as a switch that comes from all the way at the top, just behind the copy sub. And that's the network. Okay. Thanks a lot.